Hello, my name is Rob Garner. I'm be your capstone lead for the programming concentration. And so today I'm going to go over the specification um, for this capstone. So you'll get a spec like this. Your dates may be different than these depending on when you saw this video. But you will, what we will be doing is creating a portfolio and doing some debugging quizzes and create a repo of all of your programs that you've done for this degree program, the Associates of Applied Science in Programming. And there will be a time to meet where we'll do a presentation very much like this one, but I'll be able to answer your questions directly if you have any. We will meet via Teams to do that meeting, and I have a tiny URL that you can go to, and the link will be in this spec that you receive via email for this meeting. If you can't make that time and place for that, you can make an appointment with me, and I'll answer your questions there. Alternatively, because I have a Teams site for the capstone, you can also just post your questions directly in Teams, and I can answer them there. So in addition to making your capstone portfolio, you're also going to be doing a debugging quiz, and we'll talk about that. And that usually is at the end of the semester, or towards the end of the semester. And by the end of that semester, also on the same day that we're doing the debugging quiz, that's also when your portfolio will be due. So you can kind of just focus on that last date, and that's when you'll need to turn in your portfolio and complete a debugging exercise. If you can't do the debugging exercise by this time, make an appointment with me to do it prior to this. We have to complete all of our requirements for the capstone before this date. So that's actually the last date that you can complete your debugging exercise. If you want to do it a day or two earlier because of a conflict, we can do that as well. So why do we have this? We actually use the capstone to assess how well we're meeting our training objectives for this degree program. And in the requirements for this degree program, there are certain competencies that we look for in C++, C#, and Java specifically. One is to be able to define classes, use inheritance and polymorphism, make programs with graphical user interfaces and good technical documentation. Web application with a database manipulation is another requirement. Ability to see you do research with the web, i.e. Google information or whatever your favorite browser is or search engine is, and to be able to use that research to solve problems and make code. And then debugging, the ability to go through and fix code that's not working properly. So you're going to turn in a portfolio and a GitHub repository. We're going to use GitHub. And if you want to use a different method than GitHub, if you have a different way of getting me a folder with all of your programs in it, that's fine. GitHub just is one of the most common ones, and by this time, most of you have probably taken a class that used GitHub. And the portfolio is basically a document. It's going to look a little bit like this one, where you have a title page, a table of contents, and then sections with samples of your code, an explanation of these concepts, and some diagrams. So that's what you're producing, is basically a document for us to read for the portfolio. And the overall scoring will be 70% for the portfolio, 15% for the GitHub, and 15% for the debugging exercise. So for the GitHub, there should be folders. So basically, it's just a directory with multiple subfolders, each one for organized by course. So put the name of the course, CIS 1513, 2520, 1280, etc. And within that one, put the final versions of the programs you created in subfolders under that. So it should be well organized, and it should be easy for me to see all the programs you created. And don't put all just the junk in there, just put the final versions of the program. And then we will want also in there one folder that says Capstone Projects, and any projects you reference in your portfolio document will want a copy of that program in that Capstone folder. So the portfolio itself is you're going to write about each one of these concepts. And since we're going to be electronic, this goes away. It's just going to be, just upload your Word document. If we get back to face-to-face, I'll probably ask for a notebook again. We may or may not. But it should be an electronic format for now. And so you'll just upload the Word document. Let me change that. And within that, for each section, you'll need examples of code. You can actually copy and paste from, like Visual Studio into that, and it actually copy and paste very nicely into Word. And highlight the pertinent code and descriptions that are relevant. And then I need you to write about it. So it's not just put some copies of code and highlight things. I need you to explain what's going on. So the standard I'm going to be using is basically, if I were a hiring manager and you were, and I was reading this document, would I believe that you understood those concepts? So yes, I know how a class works, but what you're doing with this document is proving that you understand how to declare a class, how to use inheritance, how to use polymorphism. So you need to make it descriptive enough that it shows that you really understand the concepts. And I just showed you an example of a portfolio. You can see here where they're using arrows to point things out, and then there's explanations next to each piece of code. It is acceptable to use two programs to show one competency or one program to illustrate two topics. As long as you cover the material, that's fine. As we go through, you'll see, though, that there are instances where you kind of can't get away from it because we're asking for things in multiple languages. You'll have to include multiple programs for those instances. But as long as you cover the material, that's what we're looking for. So here, within the portfolio, these are the percentages. The presentation and the resume. I'm going to ask you to include a copy of the resume. It can be the same one you're going to give to the Capstone lead. Just include it, either copy and paste it into the Word document or include it with the Word document. And then you're going to have 5 sections in there, which will have your class one. The first section will be classes and objects. The next one, inheritance and polymorphism. And then the next one will be database. And, it'll look like you have a table of contents that will look like these 4 elements. So include a copy of this document with your submission. I will, if it's, since it's, and you can email me the Word document separately, or what probably makes more sense is put it in your GitHub repo and send me the link. The repo should be private, and then add me as a collaborator. And then you could include this document there, and you'll see my comments. I will update this document with my inputs, and then I'll check it back into the repo, and you'll see it there. If you send it by email, if you send me the document, the Word document by email, include a copy with it there, and then then you'll get it back with my comments on it. Your resume should be in there, and then there should be a table of contents that should match this very specifically. Don't come up with your own section headings. I should see classes and objects, inheritance, polymorphism, GUI, database, and Google. You shouldn't have to write any new programs for this project. You've written all of these topics have been covered in the course, so you should be able to use an existing program to do that. Doesn't mean that you can't write a new program to do it, but I recommend you use the ones that you already have done. And as we said, you should have examples of your code and comments and an explanation about what's going on. And then, like I said, it should be according to these. And the rubric also has the topics in the order. So if you match this structure, then I can very easily match the rubric against it. So we're going to go over the rubric. Document should be neatly presented, have a title page. Since you're panning me in the Word document, it should be, each section should begin on a separate page, so that you could tab them if you printed it out. And it should be easy to see what's going on and read through it. Class construction objects. Here you're going to demonstrate that you can write a class. And you'll want to show me that you can write a class in all 3 languages. So get some samples of code where you've written a class, and be sure to show how where the class is defined and where the objects are created. So remember, this is different depending on whether it's C++ or Java or C#. And so in C++, when you declare the variable as a type of that class, that instantiates an object. Whereas with Java and C#, you have to use the new command. So so you're going to show me the class definition file, but you're also going to show me the piece of code where you actually use that class. And I'll want to see overloaded constructors and functions inside of that class. So we often use that for constructors. We should see that in there. What starts dragging the points down is if you didn't show me examples in all 3 programming languages, or your explanations aren't clear, or if basically it doesn't seem to me that I would think that a hiring manager would believe that you understood this concept the way you wrote it, then that would be where it would take points down. So just describe, how the class is created and how it's instantiated and how it's used. Then the next one is inheritance and polymorphism. So in this section, you're going to bring in examples of programs where you have a class, and then you have a class that derives from another class. So you can probably imagine certain programming assignments where this was required. And you're going to find that, yes, this spec will line up with certain programs that are created, that specifically you've done. And so, Enigma would be an example of a program that uses polymorphism. Spacely Sprockets on C# might be one. There's other program, and depending on when you're watching this, there may be other programs which example that. But what you're going to see is almost all of those there will be an array or a vector or a list that's of the base class, and you assign values of the child class into that array, vector, or list. And so that's where the polymorphism derives, because the variable that's the array or the vector or the list is declared of the base type, but we put the child class objects in it, and that demonstrates polymorphism because we can put a child class object into a variable of the parent type. And then I'm going to ask you to explain what's going on with that. Explain that collection object is of the base class, and why we can put a child class object in it. And then talk about why we'd want to do that. What is the advantage of having that? Why not just make several independent classes? Why would we want to have this inheritance tree? And then talk about what the software design implications are of that in that program that you referenced. Notice that this one we don't need it in all three languages. Just one program from one language could cover this, but you could use more than one if you wanted to. For the graphical user interface, again, this is showing a console-based interface does not count for this topic. Graphical user interface, that means that there's text boxes and there's buttons and there's dialogues, and so we're looking actually for a few things in here. One is that you could make that there you can demonstrate how to use menus or tabs that demonstrate explain how custom dialogues are done, and then API provided dialog boxes. So the API provided dialog boxes are things where basically you're just using, you execute a function, a method that just, displays like maybe a pop-up window, or displays, really the one that we're thinking that you should reference here is the file IO dialog, the open file and closed file dialogs. The open file dialog is API provided. In other words, they developed the window that has a layout and allows you to access, pick a file, for example. And if you pick the file one in here, please explain how file IO is performed. If you're not using the file dialog, if you're showing like a pop-up dialog or something, please still explain in here how file IO is performed. We need to know that you know how to do file IO. And we just kind of combined it here because often that's where you can cover both. The custom dialog, on the other hand, that's a program where you have two forms and one form opens the other form. So that's actually, so don't just do the API provided dialog. We want to see the custom dialog too. Spacely Sprockets was another one where you have the main form, and then when you want to add a sprocket, you opened up another form, and it opened up a form. I think Enigma sometimes is done that way, where you open up a subform and it opens up. Now, the thing that we need to know on this is how this works. So explain how the custom dialog is instantiated, how it's opened, how you get the data back from that dialog. So remember, often you are passing to the parent form is passing to the child form through the constructor or through a property. They're passing back and forth a data class object that holds the information that the child form has so that it can get back to the parent form. So we need to see that as well. And then we should see that the program data isn't held in the GUI class. It's held in, again, a class that's off to the side, which is really our data class or our model. So we'll want to see that, and that the source code has good documentation and it runs well without obvious problems. So those are the things we want to see with the GUI program. With the database manipulation program, we want to see that you've written at least one program that connects to a database. The program provides the user the ability to obtain information from the database and modify it. So remember the acronym CRUD. We want to see that you can create a database, that you can initialize it with data, that you can modify, that you create, retrieve, update, and delete data from the database, and then explain how the database was created, where the database file is located, how the program connects to it. So usually there's some kind of connection object that you have to create, and then pass in the file name to the database. If you're using .NET, there's going to be a configuration file that has the actual location of the file or the connection string to the file. Talk about that here as in terms of the connection. And then show that the SQL statement inside the program, where you're actually connecting. So if some programs or some programming languages, you end up making SQL statements to connect to the database. Others, you're going to use link. If you're using often C#, you'll be using link statements. So show where that is and how the delete, update, retrieve statements are created and how they're used. Finally, web research. And in this one, we want you to show on 3 separate occasions with 3 different programs. Note, they don't necessarily have to be C#, C++, and Java. They could be, all C++ or all C# or mix and match. But basically, we need to see 3 separate instances where you research something and then you use that to solve something. So show us the reference page or the documentation page which you used. Show us the code that you used it in, and then explain how you got from that documentation to the code you wrote. And so we should see 3 different instances of doing this in here. So that's the portfolio. For the debugging part, which will happen on the last day, you're going to be asked to debug 3 different programs. You'll have 2 hours and 15 minutes in which to work on all problems. You'll be given a file or files of source code. They may or may not be in a already set up in a project. They may just be the source files, in which case you'll have to create a project and bring in the source files. But you'll need to put that together, then run it, and it's initially going to have compiler errors. So then you fix the compiler errors, and then you get the code to run, and then there might be some runtime errors. And finally, if you can get the code to run without crashing and it meets all it meets the intent of the program, then what it's supposed to do, then you'll get a full grade here. 3 is basically it doesn't meet all. There's something that it's supposed to do that it doesn't do. 2 is it crashes when it runs. 1 is it just doesn't even compile. So, so what I recommend too is, a lot of times you're a few classes away from your Java class when you get to Capstone. Make a Java program before you go to the debug. Just write something. Go do a tutorial. Do something. That'll help you with the Java part. Usually because C++ and C# are just pretty close together, and a lot of the final classes are C# oriented. You're often pretty up to date on this, and then it's been a semester since you've done C++. Write a C++ program. So if you haven't done one of these types of programming before you get to here, just go do some tutorials and play around with those code. That should be all you need to be able to get this to work. I think a lot of times with Java, you're in the Visual Studio IDE so much that mostly it's just you need to learn to use the Java NetBeans IDE. Okay, so that's the final thing that you'll do is the node debugging. So 3 things that you'll produce: GitHub repo with your programs organized by class and 1 folder for Capstone. Your portfolio, which is a document with a bunch of explanation of your samples of code. And then you'll do this debugging quiz. And that is what will be done for Capstone. Thank you very much.